atoms form bonds to get an octet of electrons. That makes them more stable. And there are two main ways that they can get their octet. One is by forming an ionic bond. In this case, electrons are transferred between atoms. This is how we get ionic compounds, of course. This occurs if we have a metal and non-metal. Remember, ionic compounds are the ones where you have a crystal lattice, where you have alternating positive and negative charges, and the unit is as big as the chunk of salt. There aren't individual molecules. This lesson is about covalent compounds. In a covalent bond, the electrons are shared. This occurs when you have two nonmetals that are bonding. And the compounds that have this, we sometimes call molecular compounds. These are the compounds like water. Here's a water, where you have discrete particles called molecules, and they may have attractions between them, but each of these is a separate unit. Most compounds in the world are covalent compounds. And I should mention here also that there are really two different types of covalent bonds. There are polar and nonpolar. And we'll talk about how those are different here in a little bit. Another type of bond is the metallic bond. This is not technically a bond in a compound. When you have a bunch of metal atoms together, they will have some electrons that shift and move freely throughout the metal. This is why they conduct electricity. Anyway, that does not involve compounds. That would be just a mixture. So let's look more at what's going on in covalent bonds. Okay, and we're going to draw our Lewis dot structures to show us what's going on. So here's two chlorine atoms, and they each have 7 valence electrons. You can look on the periodic table and see that's what they have. And they're going to form a bond, and you can kind of guess what's going to happen. So they're sharing those 2 electrons. That is our single bond. And when we have this, each of the chlorines, we would count all 8 of those electrons for this orange chlorine, and we'd count those 2 electrons for this one as well. So they have those 2 that are shared and kind of count for both. Another way to show a bond like this is with a dash. This is very common rather than doing all the dots. And it's understood that that dash represents 2 electrons. Shared electrons are always in pairs. You never share just one. That would be very, very unstable. And this is called a single bond, because it's one pair of electrons. You can share more than one pair, we'll see. The different types of electrons, just some wording here. This we call a bonding pair. And these electrons that are out here on the outside, we call those lone pairs. Okay, let's look at another molecule. Here is carbon. Carbon has 4 valence electrons, and the number of bonds that it can form depends on how many unpaired electrons it has. So we will expect carbon to form 4 bonds. Here's the hydrogen. How many single bonds does this have? 1, 2, 3, 4 bonds in this molecule. So this is what I was saying. Something like nitrogen has 3 unpaired electrons, and we would expect it to form 3 bonds, one on each of those sides. In a coordinate covalent bond, both electrons come from one atom. So an example of that would be if you have a hydrogen that bonded right here. This would be a coordinate covalent bond. In a double bond, you have 2 shared pairs of electrons, and that would be something like this. So those 2 dashes represent 2 pairs or 4 electrons there that are shared. A triple bond has 3 shared pairs. Of electrons.